Hi, in this video we are going to be discussing about mutation observers, and I think that's a topic that most people that develop in JavaScript do not know about, and it's because maybe there is little need for that API, but I think it's something that we should all know about because it's really useful. At least it can help you do some really cool things when you are developing in JavaScript. I found out about it last week and I learned it, and I have decided that I'll teach it on my channel too. By the way, if you haven't subscribed to this channel, consider subscribing because I release video about web development and software development in general. I'm Abdurrahman Jamil. If you have any suggestion or you just want to send me a message, you can find me on Twitter at Abdurrahman Jamil. Now, before I begin, I like to say this, that what I do is I use an application on my mobile device for coding, because I'm actually recording this video from a mobile device, and if you also code on your mobile device, you are in the right place, because everything I'm using here is just on my mobile. I'm not using any third-party applications, you understand? So the application that I'm using right now is this SPCK editor. This SPCK editor, as you can see here, that's the name of the application I'm currently using. So if you also want to use it, you can try it out. Download it from Play Store. So that's it. Now to begin, I want to create a new project. So new project, let me just name it Mutation Observer. Mutation Observer, like that. So I'll create it, and now the application I'm using has automatically created 3 files for me, which are these: index.html, main.js, and style.css. And right now I think the font is kind of too small, so let me increase the font size so it can be clearer. Yeah, I think it's kind of better now. Later on, we are going to be dealing with some HTML and CSS, but for now, what we want to work with is this main.js. But before I go to that folder, the file, I'd like to link a particular file that I use here, which is a JS script that allows me to use the console on my mobile like this. So let me pause the video and do that so I won't make this video too long. Yeah, so I've finally added the script here. Let me just show it to you. This is it here. This script here, eroda.js, is what makes me to be able to use console on my mobile device, like in the mobile browser. You know, normally the console is not available when you are using a mobile version of Chrome or any other browser like that. And so basically everything inside this box here is just for that. So it has nothing to do with what I'm going to be explaining in this video. So let me just go into main.js right now and let's begin. So basically, when we talk about, okay, there is a console log here. Let me just clear it. Basically, when we talk about mutation observers, well, okay, let me just explain it the easiest way. I think you'll be able to get the explanation. Most of the time, like, you know, we don't usually need to use this feature, but at times there will be the need for it will rise, you know. So what is a mutation observer? Just like the name of the API, it is an API that is provided by JavaScript. Like, it's a built-in JavaScript object that allows us to detect changes in the mutation of an element, or let me say a node in the DOM tree. So like most of the time we work with the DOM tree, but we don't usually need to detect if elements have been added or not. But there are times that you need that. Maybe you are developing a text editor like TinyMC, for example. I'm very sure TinyMC uses that API. So if, for example, you are like you are creating an editor like TinyMC, most probably you don't want to use that API, and it allows us to detect changes made to the current state of the DOM tree. What does that mean? Let's say, for example, this is our HTML, just a simple example, and we have a UL here, and we have one li. Maybe basically there is an attribute in HTML that allows you to be able to specify that the user should be able to change the input, like the user should be able to change the content of an element. So maybe on this UL you have set content editable to be true, which actually makes this UL to be editable. Okay, let me just create something relating to that for now. So let me go into the index.html, and inside of the body, let's create a UL, and inside of this UL, let's create two LIs. So I'll say tongue, and I'll say lip, nose, just as an example. So by the time I preview this in the browser, let me preview it in the browser. I want to pause the video for now. Yeah, so this is what the HTML code looks like in the browser at the moment. So to be able to make this element to be editable by the user, we have to set the content editable attribute to be true. So let's actually do that and see what happens. So you can say content editable and set that to true. Sorry. So let's see what happens now when I click on the UL. Let me refresh it first. And now when I click on it, it's actually editable. I can edit it now. So basically that's what that content editable attribute does. So back to the editor. What we actually want to test here is the MutationObserver object. And as I said before, the MutationObserver object is an object is a built-in object in JavaScript that allows us to detect changes made to the DOM tree. It's that simple. So maybe we've set the content editable on that UL to be true now, which means we can actually edit that UL. So we might, for example, want to detect if any change has been made to the elements under the UL, or any of the contents of the LIs have been changed. So to do that, we have to use the MutationObserver object. Now, how do we do that? Simply, we have to create a new instance for that object. Then we use the observe method of the MutationObserver object on it. What am I saying? So let's actually get the element. So let me get the UL for now. So I'll just say const list lm, like this. So I can say document dot query selector. So what I want to get the UL. Yeah, and after getting the UL, I also, okay, for now I'm not doing anything. So let me just add an observer to it. Let me just add an observer to it. How do I add an observer to it? I need to first create an observer instance. So how do I do that? I say const observer. You can name the observer whatever you like. So I have named mine observer. So new, the new keyword means I'm creating a new instance of an object. New what? New mutation observer. New mutation observer. Yeah, like that. But now we can't just leave it like this, because this mutation observer takes in a parameter, and the parameter has to be a function. let me show it to you here. As you can see here, this we have this mutation observer callback here. It's telling us that we have to pass a callback function to this constructor. So the construct, let me just pass a simple callback to it. Now we're going to make changes to this later on. So let me just say console.log changed like this. There are a lot of options that we can add to this, which we are going to be discussing about later in this video, or it's part 2, because I think I'm going to split this video into 2. So after the observer has been defined like this, we can now attach the observer to whichever HTML element that we want it to observe. So we can now say observer dot like this observe. So I can just call the observe method, and the observe method is the one that actually connects the observer to the HTML element or HTML node, because what we want to observe does not necessarily have to be an HTML element. It can be a text node and it can be an HTML element, any of the two. So as you can see here, we have the targets like this. Let you see it here. We have the target and we have options like that. We have the target and we have options. The target is the node that we want the observer to observe. So whenever it detects changes to it lets us know via this callback. So it's going to fire this callback whenever there is a change. That is, whenever the observer detects a change on the node that we pass to this observe method, it's going to fire this callback that we pass to the mutation observer constructor here. And this options parameter is the second parameter, which determines what type of change the observer is going to detect. What type of change we want the observer to detect. So for now, the node that we want to observe is this UL here that we got from our HTML. Remember that this is the UL. This UL here is the UL that we have gotten there. So it is this UL that we want to observe, and that's why I've written query selector UL here, which means we are getting that UL, and we can now attach it to the observer by writing list lm here, list lm, and the second parameter has to be these options here. And when we say the options, there are certain options that this observe method can take. Let's discuss these options one after the other. So let me just say const, or let me say let options equal to, remember that the options has to be an object. Now this object, it can take in any of the following parameters. I'm going to be discussing these parameters one after these keys one after the other. So let me begin. The first key that you can put in the options here is child list, like this, child list. Now when we set child list to true like this, what does it mean? Child list can either be true or false, remember. So that's, in fact, most of these options, in fact all of the options except for one, they are Boolean values. That is, whenever we are passing values to them, they have to be either true or false. Only attribute filter that has to be an array. We're going to discuss about that later. So child list, what does this do? What child list does is that when it is set to true like this, remember that these options here, we are going to pass it to this observe method that we have down here. Now the options here, it's the one that's going to determine how this observer observes the element that we pass here. So whenever it detects that type of change, for example the child list, what does this mean? This means that this observer actually observes these elements, and it will let us know whenever there is a change in the number of its child nodes. That's simple. For example, this UL, currently it has 2 child nodes. Let's take a look at them. We have this first li, which is the first child node, and this second li, which is the second child node. Now whenever it detects a change in the number of child, maybe you add another child node or you remove a child node, then this observer is going to fire this callback that we have here. So it's simply like that. And as I said before, we are going to discuss more about this callback function here because there is a lot you can do in it too. But for now, let's just discuss about the options that we have right now. So let me just attach this options, like this, and let me preview it in the browser. So now I'm currently in the browser, and remember that what we are doing here is that whenever the observer detects this change that we have passed through this options parameter, whenever it detects the type of change that we have specified, it's going to fire this callback here, which is to log into the console changed. So let me go into the browser and see what happens there. Now F5, yeah. So I've actually reloaded the page right now. If we check the console, as you can see, there is nothing here in the console at the moment. But by the time we add a new child node to this node here, we are going to get changed. Let's see. So remember that we set content editable to true, so we can actually edit the content of the UL. So let me just put ... and when I hit enter, now we've created another child node here. As you can see, this represents another li element. So by the time I check the console, as you can see, we have changed here because I actually added a new node to this UL, because we actually observed that's the change that we specified in the options parameter that we wanted to observe. So now we've created this new child node, and when I hit backspace again to clear it, we are going to get changed again. As you can see, 2. This 2 here means we are getting changed 2 times, because first I added a new child node and second I removed the child node. As you can see, the mutation observer object. Why? God. Yes, I'm sorry for what just happened. It's because I'm using a mobile device and it's behaving abnormally. There's nothing I can do about it. I'm very sorry for that. Now, because we set the child list here to be true, that's why we were able to fire this callback function here, and we are getting changed in the console. Now, another option that we can set to true is attributes. Attributes like this. Attributes to be true. Now, when attributes like this is set to true, what it does is that it allows us to detect changes in the attributes of whatever node that we have passed here. Let's say, for example, currently content editable. Content editable is set to true, as you can see. So if we change this content editable to false, we are going to get a report from this observer. It's going to tell us that there has been a change on the attribute, on one of the attributes of this list element here. So to detect that, to test that, let's programmatically change the content editable to be false after adding the observer like that. So let me just say set timeout like this, and function. Now inside of this function, I want to change the content editable to be false. So I'll just say, actually I'm setting this timeout to be after 3 seconds. Sorry, let me put it as 4 seconds. So 4000 milliseconds like that. So I can now say list lm dot content editable like this. It should be false. So which means that after 4 seconds, we are changing the content editable of this particular list element currently it's true, but after 4 seconds it's going to change to false, because we have set this attribute here to be true. We are going to get change in the console after it has changed, like that. So let's test this now in the browser and see what's happening. So let me refresh this. Yeah, I've refreshed it. Now looking at the console, you can see that there is nothing here at the moment, and after some seconds we get changed, because the script, the set timeout that we put at the end of the script, is going to change the attribute from being true, that's content editable, from being true to false. And after it changes it to false, the observer detects that change in the value of the attribute and then fires the callback that we have passed to the constructor. So let me do it again, refresh it, and as you can see, there's nothing in the console. After some seconds we have changed. So I hope that's understandable, and I think it's quite easy to understand. So let's get back to the editor. That's the second option that we can pass here. And lastly, we can detect changes in the text. Remember that child list only allows us to detect whether a new node was added, or a new node was or an existing node was removed, and these attributes represent that we want the observer to detect changes in the attributes of the particular element. Now another thing that we can do here is to say subtree. Let me say it that way. Now subtree, let me just set this to true. Now this subtree here, what it does is that it does not actually represent a particular change to be detected, but what it does is that whenever it is true like this child list here does not just remain on this list element. Subtree means all the trees that are below the node that is specified in this place. So you know this list element here is the UL. So if we also want to detect changes in all the descendants of the UL, we can use this subtree. So this child list is not going to work for just this list element, not just the UL. It's going to work for the UL and the LIs under it. And even if the LIs, if they have other elements in them, it's going to work for all of the descendants. That's what this subtree is for. And the attributes too, it's not going to remain on this list element. So if, for example, we change the attributes of one of the LIs there, it's going to log change into the console. So let's test that by saying, let me just remove this, and we now want to say list. Now what I want to do is I want to change one of the attributes of one of the LI under the under the UL. I want to change it like so. So let me just say list lm dot query selector li, like this. So what I'm doing now is I want to get the first li in the UL, and after getting the first li, I now want to change the id dot id is equal to, let me change the id to be list, like that. So what I'm currently doing here is that I'm changing the id of the first li in the UL. I hope that's understandable. The id of the first li in the UL, I'm changing the id to list. Remember that the id is an attribute, and whenever the attribute is changed, the observer is going to notify us by firing this callback function. Whenever it detects the changes, the callback function gets fired, like that. And the only reason why that will work is because we have this subtree here set to true, because it's the one that tells the observer that it should not just listen for changes in the list element, but the list element and all of its descendants, like that. So let me change this one from 4,000 here to 5,000, so it will be 5 seconds. So back to the browser. So let me refresh this. I'm sorry for this. So yeah, currently we have nothing here. and after 5 seconds you can see we have this changed. You can think maybe it's because it will normally work like that, but okay, I'll go back to the editor now and I'll remove that subtree attribute from being true. I'll just comment it out and let's see what happens afterwards. So we're now back in the editor, so let me comment this out like this, so it's no more available. Then we should now go back to the browser and reload. Let's see if we're going to get changed again. We are waiting, still nothing. As you can see, we haven't gotten any change here in the console, and the reason is because we set that subtree to be false. I mean, the subtree is false by default, let me say it that way. We did not set it to be false, but it's false by default. And whenever it is false, it means that the observer is only going to detect the changes made to the node, and it's going to leave all of its descendants like that. So that's how it works. Very simple. So back to the editor like this. So let me just uncomment it so we can have it back. Another thing that we can set here is character data. And we can say this should also be true. All of these keys here, child list, attribute, subtree, they are all false by default, except in some cases that I'm going to be saying later. But for now, just know that all of these keys here, they are false by default. So what does this character data do? Character data actually only applies to text nodes. It applies to text nodes, and you know, just like the name, it's actually saying it's going to make this observer to detect changes in the character data of the nodes that are being monitored. And remember that this time around, we are not just monitoring this UL here. We are not just monitoring this UL here, but we are monitoring both the UL and all of its descendants, because we set subtree here to be true. And now remember that we have a containing UL like this, and we have li here, another li here, which is what I've set in the HTML right now. Now what we have here like this, nose, I think I set one to nose, I think it's the second UL. Now this nose here is a text node. The li itself is an element, so when it's removed like that, if we want to detect changes, as we set this child list here to be true, it's going to detect the change that we actually removed the li. But for now, if we also want to detect that we made changes to the content of each of these li, we have to set this character data to be true. And that's to tell us that what character data does is that it actually monitors the node that we specify in the observe method, and if subtree is also true, it will monitor all of its descendants. And what it monitors in them is that, what it does is that it will make this observer, I'm talking about the character data right now, it will make the observer to actually detect changes in the text of either the list lm here, which is the node, or any of its descendants, because we set subtree to be true. So character data applies to just text nodes. That's it. So if we remove, let's say for example we remove this li, there's nothing there currently, we just remove it like that. When there is nothing there, we are not going to get a change in character data, because character data simply means the text nodes. That's character data applies to text nodes. Let me just say it that way. So what I'm going to do is that whenever, okay, we are going to go back to the browser. So let me remove this because we don't need it anymore, like that. And this attribute too, let me remove it because we are not detecting changes in attributes anymore. So if you want to use it in your project, you should know how to apply it like that. Now we want to detect changes in character data, so let me just go back to the browser and refresh it like this. Now currently we have nodes like this, and here in the console we have nothing here. When I enter any character here with nodes, let me just put d like this, we are going to have changed here in the console. Now the editor. So by using this character data key, we have been able to detect changes in the character data of the li inside of this ul, because the ul itself does not contain a direct text node as one of its child nodes. So because it has two child nodes, and the two child nodes are lis, so it is the lis that now contain text nodes as their own child nodes. So any changes made to those child nodes is going to make the observer fire this callback function that we have here, like that. And remember that assuming this subtree was not set to true, then that callback function wouldn't have been fired. So it's very simple to understand. And now the next key that we'll discuss is the attribute filter. So the attribute filter, I think I have to undo what I've done before. So let me leave this character data to be true. Now, attribute filter, what does it do exactly? What attribute filter does is that, actually let me remove this here. Yeah, what attribute filter does is that it allows us to specify which of the attributes of the element we want the observer to listen for changes in. That is, and this should be an array, mind you, it should be an array. It's not a boolean value like the ones we've been defining before. So let me just say attribute filter, attribute filter, like this. So let me just say id, finished, like this, which means I want this observer here. Remember that we are passing these options to this observer, to this observe method of the observer. Now attribute filter means we are listening to, remember that this attribute here is true. We are listening to changes in the attributes of the specified node here and its child nodes. Remember that we set subtree to true. Now we do not want to listen to changes of all of the attributes, but we only want to listen to changes in the id attribute alone, which means that whenever we change the value of the id attribute of this particular list lm or any of its descendants, the observer is going to fire this callback function that we have here. So here I said list lm dot id, which means I'm setting the id of the list lm after 5 seconds to be list lm, which means after 5 seconds we should get changed in the console. So let's test that. Let me refresh. So let's see if we're going to get changed in the console. As you can see, we have changed here after 5 seconds. Let me refresh it again. And the reason for that is because we set attribute filter to be id, and we are actually changing the id now. So let me remove it from being id to class. You see that we are not going to get this changed anymore because we set attribute filter to be class, and there is no id here. We are actually changing the id, but in the attribute filter we told the observer to only listen for changes in the class attribute. So let me reload it. You see that we are not going to get any change, anything logged to the console here, because we're actually filtering the attribute that the observer is going to listen for changes in, like that. So we are not getting anything here because we set attribute filter to be class. So there are a few more keys to discuss. Let's quickly go over them. So one other key to use when we are listening for changes in attributes is attribute old value. Attribute old value. like this. So this is also a Boolean value, true or false. And remember that I said all of these Boolean values, they default to false. That is, they are false by default. So we now set attribute old value to be true. What does this do? This tells the observer that whenever it detects a change in the attributes of the specified node or nodes when sub-tree is true, remember that that's going to make it extend to the descendant of the node too. So whenever there is a change in the attribute, we want to store the old value of the attributes. So let's say, for example, let me go to the index.html. Let me set the ID of this UL to be my list, like this, my list. But after 5 seconds, we are going to change the ID from my list to list lm. Now this attribute old value is the one that will tell the observer that it should store the previous value of that attribute that has changed. In our case, it's the ID attribute. So for that to work, I have to change this from being class to ID again. So because if that remains class, then we are not going to get anything in the console. Now what we want to do is we want to log the we are not actually talking about this yet, but let me just quickly implement something here. Mutations, like that. We are going to be discussing about this. I'm not explaining it now, but I just so I want to log something to the console, which is the old value of the attribute. So let me just pause the video. So what I've actually done here is that I'm going to explain this when I'm explaining the callback. I mean how we can manipulate the callback that we are going to be passing to the mutation observer object, which is going to be in the part 2 of this video. So what I just want to do is whenever the attribute has changed, which is why I'm writing if mutation.type is equal to attributes, I'm going to explain it in detail when we get to this part of the video where we are explaining the callback. For now, we are just explaining the options here. So we want to log mutation.old value, and we also want to log mutation.target dot, well, let me not do this for now. Let me just say .id, and we want to log that to the console home. So we want to log that into the console. I hope this works. And remember that what I'm doing here is that I'm changing. Let me explain what I'm doing here. I'm changing the ID of the UL after 5 seconds to list lm. That's number 1. Then I've set attribute filter here to be ID, that is, it's going to detect changes in the ID attribute. Then attribute old value, which means we are telling the observer to store the old value of the attribute when it was changed. So we can actually access the old value from inside of this callback. As you can see, mutation.old value here is what we use to access that old value that was stored. So let me now go back to the browser and see what's happening there. Let me refresh this. Now we are in the console. Let's see if we are going to get anything here. Yeah, we actually got something. So the first thing we have here is my list. Remember that we are logging the old value to the console, and I set the ID of the UL. I set the ID of the UL inside this place, this HTML file. I set the ID to be my list, which is why we are getting my list here. Then after 5 seconds, we changed it to list lm. And how were we able to access this my list? We use the old value attribute, old value property of the object that is returned, which I'm going to be explaining later, as I said before. Then the new ID, we logged it into the console too. On this line, here, mutation.targets.id. So we are logging the old value, then the ID, which is the new ID, then we are now logging changed. And that is why we have my list lm and changed here. So basically that explains it. Now we have few more keys to go. So I'm going to end the video after I explain all of the keys. Then in the next video we are going to be discussing about how to manipulate the callback function that we pass to the constructor object. Now another thing that we can do is to set character data old value. So I can just say comma here. So comma here, character data old value, like this. I can set it to be true because the default value is false. What does this do? Just like attribute old value, it tells the observer to store the previous, like the last value of the character data. When character data is true like this, that is, we are actually listening for changes in the text node of either the node that we pass here or one of its descendants, because it says subtree to be true. Now when there is a change like that, we store the old value, character data old value. So we are storing the old value of the character data that has changed. In our case, it's going to be one of the LIs, because I said, okay, I'm going to test it now. So let me just change this from attributes to character data. So if mutation.type is character data, console.log mutation.old value. Yeah. So we can now say mutation.target.data. Now what this does is that if the type of mutation is character data, that is, if there is a change in character data, we want to log the old value. You see the same old value. So we want to log the old value of the character data, then we now want to log the new value again, which is mutation.target. Now the target, I'm still going to explain this, but I just want you to understand what I'm doing. So this target is going to return the node where the change took place. So where, for character data, the target is going to be a text node, because character data actually applies to text nodes only. So this data means we want to read the current value of the text node. So let's go into the console, and whenever we change one of the value of one of these LIs that we have here, so I'm going to change the value of this nodes. Now currently you can see we have nothing in the console. Hey, we have changed here, and the reason why we get changed is because I think because of the selection stuff, that's why we are getting changed. But let me actually make a change by saying G here. As you can see, we have changed, which was the first change that we got. We now have nos. Remember that I'm accessing the old value by using mutation.old value, which is why we are getting nos, because nos was the previous value. Then the new value after I inserted G is this mutation.target.data. As you can see here, we now have nos G because I inserted G. Then we now have changed again, which is what we get here, changed. So I'm going to stop this video here. I hope you enjoyed the video. If you did, please give me a thumbs up and subscribe to this channel. And if you, as I said before, if you have any recommendations for me, maybe you just want to tell me something, or you have something you'd like to let me know, you can just reach out to me on Twitter at Abdulrahman Jamil. That's my name. I'm Jamil, like that. So if you enjoyed this video, give it a thumbs up and subscribe to this channel. I'll be creating a part 2 for this video, because I think the video is becoming kind of long. It's already over 44 minutes long. So I'm going to pause it here, and I'm going to be creating a part 2 for it later. And if you enjoyed it, as I said, do what you're supposed to do. Thank you.